Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Muhammad Aidil. So I will present on the introduction. First of all, project background. An outdoor overhead line insulator is used to provide electrical insulation between the conductor and the tower, as well as mechanical support. Insulator must be designed to have a long life to provide good insulating characteristic under any weather condition and to resist vandalism. For transmission of lower voltage up to 33 kV, pin-type insulator are used. In high voltage transmission application, suspension insulator are the most used insulator types. Suspension transmission line insulator have a normal voltage rating of 11 kV and can be adjusted for relevant transmission line voltage using several discs and has greater flexibility over other insulator type. Strain or tension is designed for handling mechanical stress at angle position where there is a change in the direction of the line or at the termination of the line. Next, we move to problem statement. The ability of overhead insulator to insulate power line and support the line conduct. The weight is considered critical to the transmission system. The proper operation of insulator is critical to the proper operation of a transmission or distribution line. To withstand the mechanical load and pressure, a good insulator should have a good mechanical strength. To endure running and flashover voltage, it should have a high dielectric resistance, and insulator must also be free of pores or void, which can cause injury. As a result, each insulator must pass a series of tests in order to achieve the desired result. One of the experiments performed on overhead line insulator is the flashover test. Before the insulator is claimed to have passed the flashover test, dry and wet flashover test will be performed on the insulator that will be designed in this project. We move to the objective. Objective number 1 is to design high voltage insulator using AutoCAD. The second one to stimulate the high voltage and electromagnetic field distribution using FEM. Third, professionally build the proposed model using 2D or 3D drawing tools. And lastly, to perform a test setup on the proposed model which adhering to a standard operating protocol that include facilities, protection, and system. The next one is project scope. Project scope number 1 is to assume the position of an engineering firm specializing in the production of high voltage insulator. Second, using stacked glass product, create a 132 kV suspension style overhead line insulator. The third one, modeling 2D and 3D drawing for the platform using AutoCAD drawing tool. And the last one, running a test on the model with finite element method magnetic FEM software, which then use the result to evaluate. Lastly, project outcome. At the end of the project, we are expecting a high voltage glass insulator will be designed by taking consideration of appropriate method and following the standard. The insulator will be designed using finite element method magnetic software to ensure desired performance of insulator. The insulator will undergoing a flashover test to be specific. It will be undergoing dry flashover test and wet flashover test. We anticipate that at the completion of the project, a high voltage glass insulator will be built using acceptable method and specification. Finite element method magnetic program will be used to design the insulator. To ensure the insulator behave as anticipated, they will be subjected to a flashover test, specifically a dry flashover test and a wet flashover test. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nazmi Shah bin Muhammad Shah. My matrix number is DE170060. This is our project, that is high voltage glass insulator designation. Okay, this is my content. I will present to you about the abstracts, company background, and organization chart. About the abstract, overhead transmission is made up of three main components, that is AC, DC, and also HV. The most popular types of insulators, such as porcelain, glass, and silicone, have been used based on their capabilities: radius splitting, pin corrosion, brittle breakup, disruption to bulk dielectric, and accidental breaking are examples of intrinsic and external insulation failure causes. For overhead transmission insulator are critical in shielding, the most costly device in the power system network. They provide robust lightweight support for pantograph, busbar, and other high voltage electric equipment on locomotive, multiple unit, and trains. For company background, the National Future Technology NFT Berhad that is established in 2020. It is one of the largest Malaysian electrical engineering companies with a proven track record of delivering innovative breakdown solutions worldwide. We aim to go beyond the normal call of duty and hope to build strong, long-lasting relationship with our client. All of our work is carried out to the highest standard and we pride ourselves on being big enough to deliver and small enough to care. This is our organization chart. As you can see, the board director, chief executive officer is me, and managing director, chief financial officer, health safety officer, engineering division, and our staff. Thank you.
Hello, Assalamualaikum. My name is Umar Asyad bin Jamaluddin. Matric number is DE 170044. Today I will continue our presentation is about the design planning. In 3.1 is about the design. Electrical and mechanical insulation strength are built into overhead line insulator. Highly insulating composite is used as well as recurring style pattern. They are the watershed film that prevent conductive water pathway from forming during rainstorm and provide the required electrical leakage insulation distance. To ensure the smooth loading of electrical stress and the mechanical integrity of line insulation, first is insulation. Material may only be driven or cold parallel side and may only be hot punched at fogging temperature. And second is hub ready of cover to shall be avoided to reduce electrical stress. And third is insulator coupling measurement are determined by material hardness. And next is extra filtrage systems are used to avoid inadvertent flashover in such highly ionized atmosphere or area with large bird size. And last is voltage and waveform test, including parameters such as water and dampness. Next, we go to 3.2 about the material. Overhead line insulators are mostly made of the following material. First is porcelain, is widely used for all type of insulator overhead line. And second is glass may be used with the disc and pin of various type. It can withstand for the high temperature. And third is composite synthetic made up of a mixture of fiberglass, rubber and resin. To reach optimal tensile strength, modern composite insulating core are often made of glass fiber in a resin-based setting matrix. And next is plastic wood, known as polymer concrete, is used for the post-type insulator. The thermal endurance of polymer concrete has been proved until 300 Celsius. It because all of the test design involve organic material, they have been concerned about the material lifetime and UV ultraviolet resistance. And second last is overhead line insulator. Coupling fitting are usually galvanized cast iron and forget or mill steel. A hot dip galvanized zinc coating on pin may be defined to shield to the base metal from extreme corrosion. And the last is each insulator should be labeled with the electromechanical filling load defined in compliance with the specific recognition. Okay, next we go to Analyze of proposal design. In 4.1 is about the physical concept. A suspension style insulator is made up of many individual insulator units that are linked by metal tied to form a flexible chain or line. And second is Towner glass has long been used in the construction of the line insulator. The proposed Towner glass insulator surface layer is in a state of extreme tension, allowing it to withstand for high mechanical and thermal stress. And the third is the insulation layer is made taller by heating it over its strength temperature while the air on its surface keeps it cool. And the last is the color on the glass insulation can affect heat absorption. The proposed hardener insulation is a lightweight, colorless and transparent material. It has lower thermal heat absorption rate and suitable for measure weather. Okay, next we go to insulator drawing. This is our design of the insulator. It uses the toughness glass material made up of 12 discs. One disc equal to 11 kV. Next we go to 4.3, material properties of toughness glass. It have a 5 point. First is high dielectric strength, and second is highly resistive for prevent the flow of leakage current from the conductor to earth. And the third is the electrical and chemical properties of the material are mainly affected by the temperature. And the fourth is the material must have high mechanical strength so that it carry the tension and weight of the conductor. And the last is free from impurity. And next we go to point 4.4, electrical characteristic of toughness glass material. The mobility of ion increases as the temperature rise, and second is the volume resistivity and the heat temperature interaction are influenced by structural effect of other material in addition to the number and the nature of the charge carried. And the last is the dielectric strength of glasses is affected by frequency, voltage, temperature and the outside test environment. In 4.5 is mechanical characteristic of Tugner glass. Tugner glass insulator are 4 to 5 times stronger than analog glass insulator. It same resistant to surface degradation. It cannot be sliced, bonded or changed. Last, it can improve its ability to resist fire. And last is 4.6 is chemical characteristic of Tugner glass. First is greater thermal resistance. Second is ability to withstand temperature until 250 Celsius. And the last is preferred as protective glass. That's all from me. Thank you.
Hi, my name is Amir Rizat Muhammad Idris, Biometrica TE17003, and the title is a high potential glass insulator designation. Alright, we are the group 4. Alright, the next is for this present is environmental performance. The glass insulators have a number of advantages, including high mechanical strength, order, pressure, and thickness. They are also ideal for the environment of the gravel, salt, and height. mixture or mixture of the three. The glass insulator can withstand mechanical and electrical overload, lowering the risk of the flash over voltage. Alright, the next is the product cost. Alright, the product cost is a total product cost is 589 ringgit, and we are also have a glass insulator design, insert the rods one, a pigtail bolts one, and insulator bolt shapeless one, and insulator bolt ears one, insulator pigtail cap one, socket clevis is one. And I'm so sorry, I forget about the glass insulator design is unit is 12 unit. Alright, and the total is 589. Alright, the next is for advantage and disadvantage of the glass material insulator. For advantage, a very many advantage. For the first is a high resistivity. The two is a low coefficient of the thermal expansion, and 3 high tensile strength. 4 is a transparent in nature, and next is the low rate of the heat up in the sunlight, and next is the easy to detect the condition, and last is inexpensive cost. Is very important. And the advantage is high voltage. The glass difficult to be cast in irregular shape due to the irregular cooling internal strain are the cause. And the last for the advantage, measure condensate on the glass surface easily has the deposit the air, but on the well glass surface which provide path to the leak current of the system. Alright, the next is for the summary. The total summary is a touch the glass insulation insulator are impervious to the influence of the time and the element forever. Alright, the properties of tall glass is summarized in the table 3. We have also the properties and glass. Declared strength, the electrical strength, 140 kV. Okay, compressive the strength is 10,000. Tensile strength is 35,000. Resistive is a 10 ohm, and thermal coefficient is 215 Celsius. Water absorption is easy to the condition. Permeability is 5 to 7. Chemical stability is very high. Alright, for the next is the technical summary of the finite the element analysis, FEA simulation for the software. Finite element method, FEMM, is a computer approach that the may use to solve engineering and science issue. Alright, this for table is a total parameter and measure the total trip pitch distance is 5,300, and length of the insulator is 1,960 ringgit, and arranging distance is 1,350 ringgit. Alright, for the next is the process flow finish element analysis, FEA simulation to the prototype. And for the first one point is that the graph pattern will be examined based on this finding will be simulated to see how the voltage distribution and electrical field intensity change over time. For the examples for the table is the set proposal define the problem geometry, define material, and define the boundary condition. And the second is design 2D model. Insulator model is designed based on the measure made and material used should be declared a design area. And the last is simulate simulation is designed and the result of the voltage and the electrical field strength is obtained to be analysis. Alright, for the next is the technical summary methodology of the FEA simulation. For this flow part of this project, the first is start, define the and go to define for propository problem, measure and boundary, and go to draw 2D model based on measure proposed, and go to set material proposed and general parameter, and go to declare material using the each area, and go to mesh of the model and go to error. Even the error is yes, if they go back to the first part and they go to set material proposed and generation parameter, and they go to declare material, and they go to mesh of model, and they set error is a no. You can go to the data analyzation and the end. Alright, for the next is FEA simulation result and data observation. The insulator is made of the glass and steel will be conduct are made of the forged steel, and the testing condition for the insulation testing are listed in table 7.8 7.1, sorry, and the material is for the material and relative permittivity is here. Alright, material for the glass is a 5 relative permittivity. For the iron is 40.2 relative, and water is 18, and air is 1 relative only. Alright, for the next is brief analysis of the FEA simulation result and data observation. To greater that is a function property, dry condition and high voltage insulator are required. The cleaning should be used to remove oxidation and the auto deposit, and will be loose during dirt and fill-up, and the procedure can be continued to the function normally without interruption. Maintenance of the insulation in itself working all the work take long. Alright, thank you, bye.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Dilil Syahiran, and I will continue present the FEMM simulation. As you can see at the screen, is our insulator, which is 135 kilovolt, and then we use the disc we use glass type, and then I will show how the simulation works. Okay, so this is our mesh button. You must click here first to look at the mesh result. Okay, after that we must click at the symbolic of the spec, and then it will come out like this. Okay, this is our density measurement of insulator. Okay, as you can see, at the purple zone has a maximum voltage, and then the blue zone has the lowest voltage, which is ground. Okay, and then we must observe the voltage and magnetic field behavior using a graph. Okay, if you want to look at the voltage graph, you can click the graph section, graph button, and then you click at you choose the voltage. Okay, as you can see, at the creepage in the picture, if the creepage distance is grow, the voltage is decrease. Okay, after that, if we want to look at the magnitude of flux density, we choose this button to look at the graph. Okay, as you can see in the graph, the creepage is not very steady very well. Okay, and then the other condition we want to look is magnitude of field intensity. Okay, if you look at the magnitude of intensity graph, is not steady well. Okay, it's not steady well state. Right. After that, we want to look at the wet condition. Okay, wet condition means that we must put the resistance, which is like such as water droplet at this insulator, and then um, it's same ways for the dry condition. For the wet condition, if you want to look at the result, we must click at the mesh button, and then the mesh result will come out. And then if we want to look at the graph, we must click at the spec symbol, and then if we click at it, so it can be like in this picture. Okay, as you can see, in this density of plot here, you can see it has also has same condition as the dry condition. You can see the purple is maximum voltage and the blue zone has the lowest voltage, which is ground. We have set it to ground. Okay, if you want to look at the graph, so we must choose the graph button and click and look for the voltage. As you can see, as well as the creepage is grow, so the voltage will decrease. Okay, after that, if we want to look at the magnitude of flux density, we can click at this section, and can we click OK. So as you can see, the the magnetic flux is not well state, meaning is not stable. Okay, you can see here in this graph. Okay, after that we look at the magnitude of field intensity. Okay, as you can see here, there is a spike between the graph. Okay, but if you can see in this graph, there is not a very well balanced, balance. Yeah, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aziz Asud bin Sham. My matric number is DE1A01A7. Okay, now I'm going to explain the conclusion for our project. Okay, the high voltage insulator will be constructed using the formal literature to examine the specific requirement required. The insulating portion can be made out of a variety of different materials. The common material used to make line insulator are glass, ceramic, and polymer. The toughened glass element was then suggested in this research. The suggested toughened glass insulator is a light aqua colorless or transparent material. Following that, the proposed model was created using AutoCAD software and is a 3D sketch. The suggested model performance with regard to environmental effect is then considered. Then the suggested model will be put to the test using appropriate standard operating procedures such as equipment, safety, and technique. The FEMM software is used to model the distribution of voltage and electrical field on a dry and wet insulator. The major material used to make the insulator was toughened glass. The insulator ability to tolerate overvoltage may be determined using a simulation approach. The simulations are carried out at the insulator rated voltage levels. The insulator performance is affected by its age. The simulation finding might aid in the design process, and the material choice to be used in place with greater lighting rates may be appropriately analyzed. The simulations are carried out at the insulator rated voltage levels. According to the findings, an insulator in a wet state might cause a flashover at a lower voltage because ionization occurs when air breakdowns occurs, which is reliant on the dielectric strength of the insulator. It is critical to maintain the insulator condition on a regular basis in order to keep it free from accumulated moisture. The toughened glass is a form of safety glass that has been strained by regulated heat treatment in comparison to ordinary glass. Tempering compress the outside surface while tensioning the interior surface cause the glass to form treeing and tracking rather than breaking into fragments. This sort of glass is additionally subjected to heat and chemical strength treatments, making it extremely difficult to break or modify. Toughened glass is frequently suggested for use in construction of high voltage insulator since it provides several benefits to consumer and is also less expensive than other material. That's all for me. Thank you.